Okay, today's notes. The only topic that we're going to cover is finding zeros. And then we're going to do a review problem. So you do need a graphing calculator in order to find these zeros. General steps are at the top. You're going to look at the equation. What's the degree? How many zeros are there going to be? You're going to need a graphing calculator to find at least one zero. What you're going to do, and this is really important, you're going to do synthetic division until you get your polynomial down to a quadratic. And then, whatever that quadratic is, you will solve it by either factoring, if you can, or if you can't, you're going to have to do quadratic formula. Easiest way to see this is just by doing an example. Okay, so first thing that we have to do when we are finding the zeros of a function, like we are in example 1, is we have to graph that function. So take out a graphing calculator, please. Man, I don't know why it keeps playing. So hit y equals and enter in the equation that you see. What you're going to do from here is you're going to hit zoom, the zoom button, right up here. And you're going to go down to the number 6. And you should see a graph. Do you see the same graph that I have up here? Okay. So our aim is to find all of the zeros. Remember, a zero is any point where y is 0. So we should be able to see a few of them on the graph. We see that there's a 0 here. It looks like there's a 0 here. And it looks like there's a 0 here. With me? Okay. Are there any that we can see very clearly? That we very clearly know what the value is? What about this one? What does this look like it's at? -4. Yeah, -4. Looks like it could be -4. Where does this one look like it's at? Maybe -2. So what you're going to do is you're going to start out with a few guesses. We're going to guess that -4 is in fact a 0. We're going to guess that -2 is in fact a 0. And so here's where we go from there. How can we confirm that -4 is in fact one of the zeros? Yeah, how have we done it this unit, besides plugging in for x? Synthetic division, and then what should be the result of that synthetic division? 0 for what? The remainder. Okay, so that's what we're going to start with. Let's do synthetic division with -4. So we have our 3, 23, 56, 52, and 16. So that gives us -12, 11, -44, and 12, -48, and 4, -16, and 0. So we do in fact get a remainder of 0. That's great. That was the first few steps. Now, it says that we need to use synthetic division to get our polynomial down to a quadratic. We started with x to the 4th. So when we do synthetic division once, we are now down to x to the 3rd. That's not a quadratic. Quadratic is x squared. So what that means is we're going to have to do synthetic division one more time. We already used -4, and that worked out for us. We also said we think maybe -2 is a 0. Now here is the key. Do not start back at the beginning. What you're going to do instead is use the result of the synthetic division you just did. So we have 3, 11, 12, and 4. There is no need to bring down the remainder. Okay, so we bring that 3 down. We get -6, 5, -10, and 2, -4, and 0. So we see, in fact, that -2 was a 0. So we did synthetic division once, and we got down to x to the 3rd. We did it again. So then after x to the 3rd, we're now at x squared and x. So if we were to translate this, we get 3x squared, add 5x, add 2. We're looking for the zeros, so that is set equal to 0, and that's what we need to solve. Okay, so we have 3x squared, add 5x, add 2 is equal to 0. We can try to factor this. If we factor, we're looking for two numbers that do what? Two numbers that do what?
0.
Two numbers that multiply to something, add to something.
Multiply to 2, add to 5.
Close.
6.
Multiply to 6, add to 5. Are there two such numbers?
Yes.
Multiply to 6, add to 5?
3 and 2.
3 and 2, yeah. Does Mrs. Ferrick split the middle? Okay, so this is going to split then into 3x and 2x. Make sure you bring down that equals 0. If I take out a 3x, I'm left with x add 1. If I take out a 2, I'm left with x add 1. How do we know at this point and split the middle that we're on the right track? Parentheses have to be the same. So one parenthesis or one factor is x plus 1. The other one is 3x plus 2. Setting both equal to 0, we get -1 and -2/3. Now, we still need to answer the question. The question is find all of the zeros. So we're going to say our zeros are -4 and -2, -1 and -2/3. Those are all of our zeros. Like, I believe Alex is the one that told us x to the 4th, we're probably going to have 4 zeros. So hence we have all 4. I don't know if Mrs. Frericks emphasizes this or not, so I'm just going to say it anyway. What I require of my students is if they have to list something as an x-intercept, it has to be written as a point. So an x-intercept would be -4, 0, -2, 0, etc. But these are the numbers that we're most concerned with. So, second example, there's nothing different. We're following the exact same process. So what I want you to do right now is take 30 seconds, put that equation into your calculator, look at the graph, and I want you to see if any of the zeros are obvious or apparent to you. So take a minute, put that in y equals, graph it, and then the question is, are any of those zeros obvious or apparent? Is that the graph that we ended up with? A little different? Can anybody confirm that their graph looks like mine? It does. Okay, great. Thank you so much. Are there any zeros to us that are very obvious and apparent?
I see
1, 2. I think it might be 3, could be 4. To me, it looks like it might be 3, though. That's the one you're talking about?
4. Oh, I see 4 of them there.
Ah, okay. I'm sorry. You answered a different question than what I was thinking. Yeah, so it looks like there's a 0 at 3. It looks like there's a 0 at potentially -1. These two, though, those are not going to be good ones to guess. It's obviously a fraction or a radical or something, so don't guess those. Guess the whole numbers. Which one would you all like to start with, -1 or 3? 3. Great, let's start with 3. So we're going to do synthetic division. We have our 4, -16, 7, 18, and -9. Remember, we're trying to get a remainder, or we're hoping to get a remainder of 0. Which we do. Sorry, my work is pretty squished. So we get a remainder of 0. What do you think were to happen if I would do synthetic division with 3 and I don't get 0 as a remainder? What does that mean? It's not a 0, or I made a mistake somewhere. So it's not a 0. So we're lucky that one ended up being a 0. So now what we're going to do is we're going to use that value of -1. Remember, though, bring these numbers down. Don't start again. You're doing synthetic division until you get down to x squared. So if we started with x to the fourth, this is x to the third. That's why we have to do synthetic division again. And so we got a 0 again. So again, started with x to the fourth, this is x to the third, this is now x squared. So we have 4x squared, subtract 8x, add 3. We're looking for the zeros, so we set that equal to 0. We can see if it factors. Hopefully if it does, it does. If it doesn't, we're going to have to do quadratic form. If we go to factor, we're looking for two numbers that do what? Multiply to 12, add to -8. Are there two such numbers? 6 and 2. Okay, question for you. Obviously this factors. Do we remember quadratic formula though? Okay, I'm going to force us to do quadratic formula now because you're going to have to do quadratic formula in your homework. Not all of them are going to factor. So let's just do quadratic formula anyway, just to review. Here's our A, here's our B, here's our C. So we get x equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be 8 plus or minus 64 subtract 48 over 8. Are those the right numbers? Yeah? Ah, okay. So this gives us 8 plus or minus root 16 over 8. At this point, can I just go ahead and divide everything by 8? Can I just go ahead and divide everything by 8? No. What do I have to do first? Simplify the radical. Okay, so simplifying the radical. This is going to be 8 plus or minus 4 over 8. So we get 8 add 4 over 8, and 8 subtract 4 over 8. So the first one is 12 over 8, which simplifies if I divide by 4 to 3/2. And this is 4 over 8, which simplifies to 1/2. So our zeros then are 3, -1, 3/2, and 1/2. And again, if she wanted you to write them as x-intercepts specifically, they'd have to be written as points. Okay, the examples we've done so far, every 0 has been a real number. That's not always going to be the case. Sometimes you're going to have to do quadratic formula. Sometimes you're going to end up with zeros that have an I in them. So just be aware of that. What I also want to tell you is sometimes what students will do is they'll see this graph and they'll say, well, I know what all 4 of them are. It's -1, 1/2, 1.5, and 3. And they just list those 4 values. If you do that without any of this work, you will not get credit. What other students will do is they'll do synthetic division 4 times with those 4 values. Again, you will not get credit for that. You are only allowed to do synthetic division until you get to a quadratic. As soon as you're at a quadratic, you have to solve that quadratic. We have one last problem to do. Questions before we move on and do a review problem. Okay, flip the page. Those of you who took math applications last semester, we did quite a few of these box problems. You got a piece of cardboard and you're cutting the corners out and you're making a box and you want to look at the volume. We're going to do one of these and this is the end of the notes. A company constructs boxes from rectangular pieces of cardboard that measure 10 inches by 15 inches. An open box is formed by cutting squares that measure x inches by x inches from each corner of the cardboard and folding up the sides. A, express the volume of the box as a function of x. Okay, this one's pretty nice because it gives us a figure. First thing to review is how to find volume. volume of a prism is going to be length times width times height. We are told that our volume has to be a function of x, which means the only variable that we are allowed to have is x. So on the left, we have our flat piece of cardboard. On the right, we have the box that's formed. What's nice about the figure we're shown is we know that the height of the box is x. So what we have to figure out is how do we determine the length and the width. This part of the length right here, and then this is our width. What I want us to recognize from the flat piece of cardboard is that 15 is not the length. 15 is the entire side, but this part is the length. So 15 is the whole side, but then we cut out x and we cut out x again. So our length is 15 subtract 2x. Similar idea for the width. All of this is 10, but we cut out x and we cut out x again. So our width is 10 minus 2x. So our volume as a function of x, the length is 15 minus 2x, the width is 10 minus 2x, and the height of the box is x. That's it. Don't multiply that out. That's it. Part B, determine to the nearest hundredth of an inch the x value that maximizes the volume of the box. We're not totally going to do that. We're going to talk for like the next 2 minutes and then we're going to be done. What I want us to do is sketch a quick graph of the shape that this would take on. So the first thing, if we were to multiply all of this out, what would be the degree of that polynomial or that function? 3. So we have x, x, and x. So we would have 3. What we care about is that that degree is odd. What would be the lead coefficient? That one is a little bit harder to see. If we were to multiply everything out, what would be the number in front of the x to the third? Close. It involves the -2. 4. So we would have this -2, and then we have that -2, which would give us a positive 4. Okay, so what we know then, because our lead coefficient is positive, we're going to end up, because our degree is odd, we're going to start the opposite direction. Okay, so my question to us then, some things happen here, but we don't really know what that is without looking at a graph. Do we have, on this graph, an absolute maximum? Is there an absolute maximum or an absolute highest point on the graph? No. Because the graph forever goes up. Now, that being said, in the middle of the graph, what ends up happening is you end up with something like this. So when it says find the maximum, it's talking about this point right here. What is that? How would we label that? A local maximum. So that is a local maximum, which we could find. We don't care to. I'm not going to ask you to. It's something on the calculator that's not really that important. What's most important is being able to write the function in part A, and then in part B, recognizing that yes, there's a local max, but there's no absolute max.